Dear ladies and gentlemen, I am glad to welcome you to the conference devoted to the practical application of autonomous navigation, the event we hold with the support of the International Maritime Organization. Next week, the 103rd session of the IMO Maritime Safety Committee will be open. Among the key topics of its agenda, the members will discuss the results and further steps on the regulatory scoping exercise RSE on maritime autonomous ships. Autonomous navigation or a-Navigation is undoubtedly one of the most important areas of international cooperation in maritime transport. These global efforts shall be resulted in improving safety by preventing human errors and implementing better working conditions for seafarers. Our participation in the IMO RCE doesn't limit Russia's contribution to this joint work. We have begun a broad practical application of autonomous navigation technologies, which is necessary basis for any further development over both legal regulation and technologies. Only the extensive practical operation of autonomous navigation by shipping companies can provide the answers to many questions, and not only to give a response to the existing questions, but also to identify the new ones. Before the practical operation started, we didn't even see a number of tasks and the problems that hadn't been discussed earlier, either in Russia or globally. This year, we are completing a large-scale navigation trial project in real condition and beginning a national experiment on the trial operation of autonomous vessel under the Russian flag. In December last year, the Russian government, the flag state administration, approved the decree on a condition such an experiment considering the IMO's interim guidelines for maritime autonomous ships trials. In accordance with it, any shipping company will be able to equip its ships under the Russian flag with autonomous navigation systems and operate them in their regular activities as part of the national experiment. Other speakers will tell in detail about the conditions of the experiment, legal regulation and technical solutions which were developed within the framework of a navigation trial project for the operation of autonomous vessels. And I want to share a few short videos with examples of the ongoing tests within the trial project. We will show you the most part in an accelerated mode because even the shortest test within the trial project lasts about 1 hour. But we will send links to full videos in real time to the conference participants afterwards. The complete set of autonomous navigation systems was installed in September last year on 4 different vessels of the Russian shipping companies. That is Rosmorport, Polar Group, and Sovcomflot. The vessels are in commercial operation with different missions and in different areas. Dry cargo ship of Polar Group operates in the Mediterranean, Black and Caspian Seas. 2 vessels in the dredging caravan of Rosmorport operate in the Azov and Black Seas. The Sovcomflot tankers operate in the Bering Sea in the Arctic. Technical supervision is carried out by the Russian Maritime Register of Shipping. All this time, the systems continuously collect and analyze data and transmit it to the shore. by the decision of the ship's captain. When the crew load and surrounding conditions allow, the ship autonomous control is activated, and the ship is controlled in various autonomous modes, automatically or remotely, on specific route segments under the permanent supervision by the crew. This allows us not only to improve the functionality of technical solutions, but to develop experience in using navigation in the practice of shipping companies, its implementation into the company's safety management systems. The full-scale tests are now being carried out only on the vessel of Rosemark Port and the Polo Group. The systems on the subconfloat tankers have not yet been connected to the actuators. Due to coronavirus restrictions, it hasn't yet been possible to deliver on board an engineer from a manufacturer of actuation control system abroad. We expect that subconfloat will be able to organize this in the near future and will begin trial operation on this vessel as well. As I said before, thanks to the practical experience, we see a number of new issues in the field of navigation technologies and regulations. We have a number of ideas for the development of these technologies, and we are ready to share this experience with all interested parties. And an important feature of our approach is that we are introducing autonomous navigation within the framework of the existing international regulation, and that is applicable to existing retrofit vessels. This opens up the possibility of such approach implementation in any other country in different shipping companies. Please enjoy this short video. I will continue in a minute. Okay, so we can go on. Russia has opened up the practical operation of a maritime autonomous vessel and calls upon all countries to join this approach, which will provide exceptional opportunities to improve the safety and efficiency of the entire global maritime transport industry. We work not only for the interest of the Russian industry, but for all mankind. We are open to share experience, and we hope that this will become a valuable input for many shipping companies and ports, for the maritime administration of different countries, and for the IMO. On this, I want to pass the floor to Ms. HEIKE DEGGIM, Director of Maritime Safety Division, International Maritime Organization. Please.
Okay,
I'm so sorry. I just noted that I was muted, the usual feeling that happens at Zoom meetings. Sorry for that. I'm starting again. Deputy Minister POSHIVAI, distinguished participants, ladies and gentlemen, thank you very much for inviting IMO to participate in this conference on autonomous and remote navigation. It is a pleasure to be here. IMO's Maritime Safety Committee has been discussing the matter of regulating maritime autonomous surface ships, or MAS as they are now universally known, since 2017, when the 98th session of the committee took place. At that session, the committee considered a joint submission by Denmark, Estonia, Finland, Japan, the Netherlands, Norway, the Republic of Korea, the United Kingdom, and the United States, proposing to undertake a regulatory scoping exercise to determine how the safe secure, and environmentally sound operation of MARS might be introduced in IMO instruments. Since then, the work has been progressing steadily. MSc 99 in May 2018 defined the aim and objective of the regulatory scoping exercise, the preliminary definition of MARS, and the list of mandatory instruments to be considered. MSc 100 in December 2018 approved the framework for the scoping exercise, including the work procedures, and also a new GESIS module to facilitate the exercise was developed. And MSc 101 in June 2019 continued the scoping exercise and also approved the interim guidelines for MARS trials. That was MSc Circular 1604. Following MSc 101, we had an intersessional working group on MARS, which met in September 2019 and progressed the work even further. At the same time, the legal and facilitation committees of IMO also commenced a regulatory scoping exercise of the instruments under their purview, while the Marine Environment Protection Committee decided, taking into account its heavy workload, to consider MARS in the future when significant progress would have been made on the matter by the Maritime Safety Committee. But with the COVID-19 outbreak in early 2020, we hit the buffers for a while. The program of meetings at IMO was severely disrupted since physical meetings were no longer possible, and it took us a little while to adapt to the new way of working through remote meetings. We have now started to take up the slack again, and at MSc 103, which will take place from 5 to 14 May of this year, the intention is to finalize the regulatory scoping exercise. Traditionally, IMO instruments have been developed based on the assumption that crew are on board a ship, at the same time allowing for increased automation of systems and supporting services. Looking towards the future implementation of autonomous systems, this new concept is not limited to ships with crew on board, but also includes unmanned shipping. As such, existing IMO instruments in the current form may prevent the realization of MARS operations in certain instances. There are many concerns with regard to the effect of the introduction of autonomous ships on the safety of navigation. One of the main issues for discussion is the interaction between conventional ships and autonomous ships. In this context, it has been recognized that the Collision Regulations Convention is one of the most critical instruments. Views have been expressed that some amendments to COLREG are required in order to accommodate the use of future autonomous shipping without seafarers on board. However, there is general agreement that COLREG in its current form should still be the reference point, and its current content should be retained as much as possible. The STCW Convention has also been identified as a critical instrument, since the introduction of MARS without seafarers on board would transfer the role of officers on board to the remote operator or another entity for whom training, certification, and watchkeeping requirements should be established. The objective of the regulatory scoping exercise is to assess the degree to which the existing regulatory framework may be affected by MARS operations, and to identify items for further discussion in the future. Finalizing the exercise will enable member states of IMO to submit proposals for substantial work on MARS to upcoming sessions of the committee, such as the further development of definitions relating to MARS, for instance, MARS itself, remote operator, remote center, etc. We will also start amending existing instruments and maybe developing a new separate instrument addressing MARS operations in accordance with the results of the scoping exercise. And we also need to update the interim guidelines for MARS trials. The longtime chair of IMO's working group on MARS, Mr. HENRIK TUNFORS, senior maritime advisor at the Swedish Transport Agency, will now inform you in more detail of IMO's work on the regulatory scoping exercise and its outcome. Thank you.
Thank you very much.
Thank you, Heike. Let me just share screen. Oops. Wrong way. Sorry for that. And you get to see the presentation. Okay, so I hope you all can hear me. My name is HENRIK, and I'm delighted to be addressing you here. And I want to thank the Russian Federation and MARINET for inviting me to this conference. And also, good morning to everyone, distinguished delegates, participants, minister. So today's presentation, I will focus on a bit on the regulatory scoping exercise, as also Mrs. DEGGIM alluded to, something on the early results of the scoping exercise, a few words on the next steps at the IMO. I will also linger a bit upon the interim guidelines for mass trials, and then I will try to sum up. What is the regulatory scoping exercise? Well, as Heike explained, it was in 2017 that MSC 98 agreed to work on a regulatory scoping exercise for the use of maritime autonomous surface ships. And the initial target completion year was 2020, but as you all know, we are now hoping for 2021 and MSC 103, which commences next week. And so what are we trying to achieve, or what's the process and methodology? As Heike explained, we adopted a framework for the procedures, and it was a two-step process. And the first one is to determine which IMO provisions apply or not apply to mass, and if they preclude or not preclude mass operations as currently drafted. We also found it wise to identify common gaps and common themes which go horizontally throughout the instruments. I will touch upon that further on. And the second step is to analyze the best way to address mass operations in the different instruments. So it's a two-step process. And of course, we needed to sort of define what mass is, and otherwise we won't know what to look for in the regulations. And this is for the purpose of the scoping exercise, we developed mass defined as a ship which to a varying degree can operate independent of human interaction. That's quite uncontroversial, I think. But it's also quite generic, so we needed to be a bit more specific. So we then looked into different degrees or levels of mass. And we ended up with 4 degrees, where the first one is ships with automated processes and decision support. You have seafarers on board. It's basically a conventional ship of today, but with technology on board, which we don't have today, or at least approved equipment of today. And then we have the degrees 2, 3, and 4. This is where it becomes more interesting and more complicated, because we have the remotely controlled ships with seafarers on board, degree 2, and then without seafarers on board. And that's going to be a challenge, as Heike also explained. And then we have the fully autonomous ship, where the operating system of the ship is able to take decisions and determine actions by itself. So there's no human interaction or no human decision making when it comes to the navigation of the ship, for example. Just a brief explanation also on the instruments considered. As Heike explained, we have come quite far now in the process. The results of the step 2 results has been sent into to the organization. It was actually a year ago now, and we're supposed to debate the results at this meeting, MSC 103, and hopefully having a finalized picture of how to address mass operations. And the MSC, the Maritime Safety Committee, where my working group is situated, we have 13 instruments to consider. You can see them on the left, and Heike mentioned a few. Colregs is essential, of course, but also SOLAS is one of the key instruments together with STCW, etc. But there are also 19 codes, international codes, which are put into force through these instruments shown. So it's been a massive task, and it's been an impressive determination shown by the individual IMO member states and other interested parties to get this first and second step done this far. But you can also note, as mentioned by HEIKE, that there are also activities taking place in other committees, the Facilitation Committee and the Legal Committee, for example. And some of those instruments are shown in red. And the MARPOL Convention is in brackets because MEPC, the Marine Environment Protection Committee, hasn't yet started their exercise. That was a bit about the scoping exercise, and what about some of the early results? This, as you know, we have put out a working paper, or a J paper as it's called at this stage, showing some of the early results, and this is actually early results as per Swedish preps that we did before. But I just want to show, it shows, I think, quite clearly the difference between degree 1 and the other degrees. And I think that's not a big surprise to anyone having been involved in the scoping exercise. So basically no reactions required for degree 1, and it becomes more complicated when we reach the sort of higher degrees. So that's, I think, something that we anticipated before the exercise, and it's good in a way that we get the result we anticipated, sort of. So I only want to mention briefly also that this is the IMO exercise, but there are also other non-IMO agreements out there that we need to look into. For example, the Visby Hague rules, that's not part of the IMO remit, but I think we need to get a complete picture of the different barriers, legal barriers. I think we need to look also beyond IMO instruments to make possible mass operations globally. I mentioned also briefly that we developed or discussed common gaps and themes. That is terms and yeah, you could say activities or roles which go horizontally throughout all instruments, and if we can solve those common gaps and themes, meaning of master is of course the most central, as you can see in red. If we can solve that in one discussion and have a result, we can have an effect throughout several instruments. So this is also a part of the scoping exercise, and hopefully this will be taken further at the IMO, also beyond the scoping exercise, so that we can have that sort of ripple effect throughout all the instruments if we solve these gaps and themes as shown here. But these are only preliminary. They haven't been discussed or agreed at MSC. That is something that we need to address at MSC 103 next week. But I just want to show you so you get a flavor of what's coming. But then a few words on the next steps at the IMO. This is my own reflections, basically, but it's also been discussed at MSC, of course, and by individual member states. But we need to have a strategy. We need to have a structure in order to take the mass operations issue further in the IMO. And I think we need to have a roadmap to show the sequence of individual instruments when they should be amended, or at least when we should have deliberations in subcommittees, for example. And that also goes for other main committees such as Legal Committee and Facilitation Committee. We probably need to revisit the terms and definitions. As I said, the 4 degrees were adopted or agreed for the regulatory scoping exercise, and of course, coming from the IMO, they have a tremendous effect on the shipping industry and administrations. But there is work done at ISO, for example, and I think we need to at least open up a discussion on the terms and definitions together with other interested parties. MEPC is a key here as well, and we are aware of their heavy burden, but I think we need to get MEPC involved in order to scope one of the other main conventions of the organization, that is the MARPOL Convention. And the next one I think is one of the more important. We need to increase knowledge in industry and in administrations. Decision makers needs to be aware of the potential impact of mass, and also the promise of the use of digitalization as a means to have better sustainability in the industry. For example, trial experience is very important here, and I'm delighted to see all the activity in Russia and the Russian Federation, for example, both when it comes to trials and testing, and also regulatory work. But we need activity also, and that goes for IMO members in general. In order to take this further, we need outputs to be submitted, or proposals for new outputs. That's a key activity, both in administrations and in industry. And we can only guess when we have an end result. I'm not going to guess, but it depends on activity basically and determination. A few words on the interim guidelines for mass trials. You're very much aware of them in Russia, of course, having used them. They're very high level and generic, and that's I think a key. You have a function approach to them, focusing on roles and responsibility on relevant authorities and stakeholders, and also compliance with mandatory instruments should be ensured. That's one of the main principles. And as mentioned by HEIKE, these are to be kept under review, using, of course, the experience gained from individual trials. And just a brief something on the principles and main objectives of the mass trial guidelines. Risk management, of course, is a very heavy and important section in the guidelines. And also information sharing, as highlighted in blue. Information sharing is key. As I said, we need to share information to heighten awareness and knowledge in industry and in the administrations. Finally, summing up, the RSC is ongoing. Hopefully, we will finish it. The deadline was 2020, and probably, hopefully, we will finish this in 2021 at MSc 103. I think the early results are promising. The guidelines are there in effect. Use them. All stakeholders, be active. And we need outputs to start the next phase, which would be drafting. So I'm sorry if I spoke a bit too long, but I hope this was entertaining. It's not the word, but I hope it was giving to you. So here's my contact information. And now I'm gonna stop sharing my screen and give the floor to Maxim. Thank you.
Thank you very much. And yeah.
Well, colleagues, I'm sharing my screen. Can you see the presentation? Maxim? Okay, so good morning, dear colleagues. I'm Alexander PINSKIY, Head of Industry Association MARINET, the author and the leader of navigation developments in Russia. As Mr. Deputy Minister said, we see our important contribution to the navigation developments in support of RCE and other activities by the practical experience. So in 2019, we, together with a group of technology and shipping companies, had gathered with the idea how to make possible wide practical operation of autonomous navigation in the nearest time. You know, I strongly believe that new technologies are developed in reality, not in scientific centers or in R&D labs of technology companies, but by consumers, utilizing them in their everyday practice. Look, for example, on aerial drones. We have the existing drone design developed more than 20 years ago, but the real breakthrough came only after these drones became available for every company, even for every person. As soon as thousands of people and organizations started to use aerial drones, we saw hundreds of new ways of their usage, from TV cameras to pizza delivery and so on. So, and we see the real technical boom in this industry. The same should be done in the maritime industry as well. We need to open the opportunities for every shipping company to try and to implement autonomous navigation solutions, and we will see the real and fast technology development in this area in very, very soon. So we analyzed main obstacles and defined the following challenges. The first one is that the functionality and behavior of autonomous vessels should be transparent and predictable both for ship owners and for other participants of navigation. Implementation of a-navigation should be done within the existing international regulations, since changing is a long and difficult process. Moreover, since we are focused on a practical side, for us the current international regulation is not even an obstacle, but is a ground for our developments, since it is an embodiment of the practical experience of millions of seafarers during many years. And definitely, a-navigation should be affordable for shipping companies. They cannot be very expensive or sophisticated. Otherwise, the benefits from safety increase and potential crew number decrease would be eaten by cost of a-navigation implementation and operation. And they shouldn't require completely new types of ships, meaning that we must to be able to equip with a-navigation current ships, the retrofit fleet. To respond to these challenges, we have developed our functional-based approach named the Complete Functional Equivalence Principle, and the system architecture utilizing as much as possible the existing technologies. So, the Complete Functional Equivalence Principle supposed that an autonomous ship shall fulfill the function prescribed today for the crew on board by the current safety regulation. This guarantees that mass, when interacting with other actors, will be guided by and perform well-known and mandatory functions. So it makes the mass operation predictable and understandable for everyone, removing these fears about unpredictable artificial intelligence black box systems. At the same time, it also allows for mass operation to fit within the existing framework of international regulation as is, without requiring any immediate change implementation. In order to implement this principle, the project identified key functions provided for by the current regulation. The basis is International Convention for Standards for the Training, Certification and Watchkeeping of Seafarers, since it is already grounded on the functional principles. The STCW Code Part A in the second article specifies the functions corresponding to the competence standards of crew members, navigation, cargo handling, etc. Additional requirements for each of these functions also can be found in the SOLAS, COLREX, and other international and national regulations, providing a pretty complete picture of functions performed by the crew on board now. So we assessed how the existing functions or part of it may be automated or done in the remote mode. For example, navigation or engineering control, or transfer it, like cargo handling, which may be performed by shore workers. By the way, the same approach was proposed in several comments submitted recently to Maritime Safety Committee, for example, by China. And here you may see high-level map of this projection. Green zone, what can be done automatically right now. Rose zone, what will require partial human involvement like the remote control. And red, what we see as a human responsibility for now. For example, care for people on board, rescue operation, emergency and extremely difficult conditions. So this map was the basis for the next step, the system architecture development. The system architecture is, on the one hand, the result of the overlay on this previous functional map of technical systems already used by shipping companies. You remember that we need to make it affordable and applicable for retrofit vessels. So we have to utilize maximum of the existing solutions like navigation devices, engineering systems, engine and technical control, autopilot, speech pilot, track following system, signaling, communication, and etc. So we tried to cover this functional map by the existing systems as much as possible, and only several gaps had required new developments. These new developments include optical surveillance and analysis system, equivalent to human visual control, both in automatic and remote mode, autonomous navigation system, which can automatically combine data from different sources, recognize navigation dangers, and make decisions for maneuvering to avoid these dangers. And the remote control station, enabling to perform on the bridge control functions, but outside the vessel, and permanently monitor the vessel in the automatic mode. Further, Sushinsky will talk about these systems in detail later. On the end, we use here somebody is on. If I might to mute it, thank you. So, on the other hand, we used outputs of the Munin project, which was completed in 2016. You remember that under the Munin project, a consortium of organizations developed the concept of autonomous vessels and modeled its application in the practice of a shipping company in a simulator. I personally consider Munin as the first milestone in the modern development of air navigation. They did it theoretically, and we actually do the same in practice. You may see that even our system architecture has many similarities to the reference architecture developed under the Munin project, but it's definitely much wider. And I would like to stop on a few other important inputs on the Munin project, which we confirmed by our project. This is first of all a combination of various ship control modes. The same as Munin, we consider 4 levels of autonomy defined by the IMO, not as a different types of autonomous vessels, but as a levels of control autonomy, which could be combined at the same ship and even during the same voyage. For example, full automatic navigation is used on a passage in the high seas, while the exit and entry to the port are carried out by a pilot on board, when the human control should be more efficient, including economically, rather than installation of new additional systems. We plan that at least 80–90% of the time, the vessel can be safely managed in the automatic mode, and the rest time by the remote operator. And only in some limited cases, like pilotage or emergency cases, we will need human control on board. Also, as Mr. Deputy said, thanks to the practical operation, we see a number of new tasks and opportunities, and one of them is a combination of A-navigation and E-navigation. E-navigation is a natural infrastructure for autonomous vessels. The unified and standardized maritime information space is able to unleash the full potential of autonomous vessels and to be common ground for them and traditional vessels. That's why I think we need to synchronize developments of e-navigation and A-navigation standards and technical tools. For example, in the next years, we plan to combine in St. Petersburg, VTS and remote control office of Rosmorport, which will allow to control autonomous vessels of Rosmorport from one place and in conjunction with VTS services. I believe it will be some kind of a prototype of huge mass navigation control center that allow to control mass not only by shipping companies, but by such navigation center operator in the area of its responsibility. And now I'd like to show where we are currently with the trial project progress. So in 2019, we have developed a methodology and solution prototypes. Then we made risk assessment and draft legislation development, including interpretation of COLREX provisions from human view, which is sometimes uncertain and ambiguous, into the strictly determined view to allow its implementation in automatic systems. We shared this information with the IMO members in 2020. As HEIKE said before, we consider it is extremely important to follow COLREX rules right now with automatic and remote mode. Then we have manufactured the experimental equipment and installed it on board 4 ships, which are in real commercial operation. These are vessels of Polar Group, Sovcomflot, and Rosmorport. In Rosmorport, we have, by the way, very interesting and unique experiment when the remote control station is installed not ashore in a shipping company office, but on board another vessel, the head ship of the dredging convoy. We believe that such convoy navigation could be useful in certain conditions, for example, in the Arctic, in ice conditions, when RCS remote control station on board icebreaker leading the convoy. Will work for autonomous vessels following the icebreaker in the convoy. Since within the enough trial project, we are following the prototyping approach and develop solutions during their practical probation. The systems installed on board, they're installed as additional equipment and don't impact the class of the vessel. Then we made preliminary test of systems on shore using dedicated simulators. And from September, our systems are working on board, but without the possibility to control the ship. So they collect data and propose actions, but without access to actuators. From this September, we started tests of automatic and remote control of ships under the supervision of crew and with additional supervision by the shipping company. You saw the example of such test in the beginning. You will see the full video in real time. It's about 1 hour, so you will see how it looks in reality. In parallel, we are completing the mass national regulation adoption. VITALY KLYUEV will present it next. So in June, we plan, we hope, to have the federal law approved, to complete the technical test, and to arrange demonstrational voyages with the participation of Russian government officials and representatives of international organizations. Truly saying, we plan to do it at the end of the last year, but coronavirus has shifted our plans. Maybe even it could be even to the good, because in summer maybe we will see some removal of coronavirus restrictions and we'll be able to invite for demo voyages not only Russian colleagues but also from other countries. And then we will be ready to equip MES within the national experiment by, mentioned by Mr. Deputy Minister. So we will equip with a navigation system the rail ships already as a main equipment, adding autonomous class to the vessels, in contrast to the current state of additional equipment within the trial project. The colleagues have already signed several memorandums of intent for a number of ships and waiting for the final legislation approval and technical products. Sure, we still have a number of tasks to do. We continue to add new interfaces and features required by navigators. We look and fix defects which are found during trial operation. We have some significant points to be improved in the optical system in the autonomous navigation system that we described in our report to the IMO. So right now, it is not a commercial product yet, but we are very, very close. What is important? As you might see from the video in the beginning, and you will see it even better in the full video in real time, this trial operation looks very routine. And that is exactly what we want, to make a-navigation routine, friendly for seafarers, for shipping companies, to implement it smoothly and gradually without dramatic changes for shipping companies. And not only for Russian companies, but for the entire maritime industry. We are the first to gain unique practical experience how to integrate a-navigation into the current national regulation, how to apply its technical solution in the operation of shipping companies. And we are ready to share this experience, to make joint projects and developments. We wish you avoid the inevitable mistakes that we have already made and will make along the way. So we invite for the cooperation, and here I would like to give the floor to VITALY KLYUEV, the author of our national mass regulation development. So VITALY, please, your turn, and I'm stopping sharing my screen.
Okay. Dear Deputy Minister, dear colleagues from IMO, from Maritime Administrations. Currently, I'm acting as Director of Department of State Policy for Maritime and River Transport in Ministry of Transport of the Russian Federation. And this department is responsible, as you can see, for policy developments and legislation development and implementation in Russia. And one of the responsibilities of this department is relationship with IMO, including the topic under discussion now, which is MAS. My presentation will focus on legislation only, and legislation mostly related to national point of view, Russian approach to autonomous vessels, how we look current situation and what we expect in the nearest future. And I'm underlining nearest future. Couple of years ago, we understood that technical solutions which approach into our life may be implemented in real shipping activity, but existing legal environment may not only support but even prevent utilizing those technologies related to autonomous vessels. And if we do not introduce proper legislation, the real implementation of technologies would not be feasible. The same as IMO 3 years ago came to the similar conclusion. We initiated our national investigations similar to IMO investigations on global level. We initiated investigations on the national level, and the scope of those investigations more or less similar to investigations introduced earlier by our colleague from working group of IMO, HENRIK, TUNFORS. But our challenges were more difficult in some stage, so it is necessary to confirm compatibility with international legislation, with international legal environment for our national scheme. I would say when I was a child, many years ago, I don't remember that time, but I dreamed in shipping, in seafarers work, and one of my favorite book was Ships and Shipping of Future. This book was issued by Rostock University, Germany in 1973, approximately 50 years ago. And some quotes from that book you may see. In 1973, the people looking ahead stated that in some future, no crew ships feasible and shipmaster will located in some comfortable office ashore, not on the ship. And the deputy of a shipmaster would be a computer located on board the vessel. Now we approach into the future proposed to us 50 years ago. By the way, these books still in my bookshelf, and from time to time I look on that to develop legislation, modern legislation in Russia. Challenges we met when we initiated our own developments. Number one is approach, which was declared by Alexander earlier, applicability of technical solutions and legal developments to existing vessels. Then compatibility with non-autonomous vessels, which will be operated very long time on our understanding, and at the same time with autonomous vessel. And both of vessel types should live friendly to each other in the sea. The basic approach which we should take into account is compatibility of our developments with existing known international requirements. We should develop our national legal scheme so as to not violate anything known at the moment in conventions, international conventions. Of course, our national legal law, legal language is very different comparing with international instruments in which you are more flexible. You may say some things to be interpreted by maritime administrations. We are maritime administrations. We cannot refer to anybody else, and we should put in our legislation everything in the language we use in our national legislation, and this language should be compatible with international language. Of course, when we started our development, we understood that IMO progress, IMO developments should be taken into account to be in the future in line with what would be developed by IMO in the convention. So the challenge for us was to predict how the RSE would finalize to be in line finally with the outcome of IMO efforts. What we achieved. We used full or comprehensive functional equivalency in our developments, and every requirement we're introducing now addresses to the existing functions of crew on board or shipping companies dealing with non-autonomous vessel, and those functionalities should be fully implemented in autonomous vessels through legislation we are developing. National legislation we drafted may be applicable to new built vessels, which is not under construction yet, or maybe in some future will only be constructed. But any existing vessels may be transferred to autonomous style, and the legislation allows to do that. Our national legislation drafted, from our point of view, fully in line with the international regulations, and we approached in the development so as to address every point in known conventional requirements to existing vessels, which are not autonomous ones. And of course, our developments, in most cases, in line with IMO progress just reported to us by leader of the working group on mass. What we did and what we expect to do in the nearest future. Last year, December, our government approved a special legal act introducing experiment of Russian flagged vessels in autonomous mode. This experiment will continue starting from year 2021 and until 2025. We reported these arrangements to IMO Secretariat. The IMO Secretariat very recently distributed this information to all IMO members. Also, comprehensive legislation is now drafted totally, and we completed the drafting stage of the legislation, comprehensive legislation introducing autonomous vessels, and we expect that this year the Russian Parliament will finally decide on that legislation. Now this legislation is going to the Parliament. We expect May or June at the latest to come to the Parliament. And finally, when experiment will be completed in 2025 or before that, or before the end of the experiment, we expect to adjust legal arrangements, the legislation we introducing now, depending on the results of experiment and also depending on the progress made by IMO. And the idea is to be in line with IMO developments fully by 2025. What is interim arrangements I mentioned, government legal act from last year. These national arrangements only, it's not international one, for mass trial. Again, it will continue for years, and the results will be reported nationally and will be reported to IMO as well. Of course, we so developed those interim arrangements that every vessel participating in the experiment, in the trial, should be in full compliance with existing applicable IMO instruments. And of course, our national arrangements in full compliance with interim guidelines for mass trials recently approved by IMO. Supervision of the experiment is done by Federal Agency on Maritime and River Transport, which is under supervision of Ministry of Transport of the Russian Federation. Separate point is, or specific point is KLYUEV Convention. It was a huge discussion on that in IMO, and it was a huge discussion internally in Russia how to address those requirements in this trial. And we developed, as already mentioned by Alexander, formal treatment for mass implementation of KLYUEV. Also, approaches to this formal interpretation of KLYUEV reported to forthcoming MSC 103 session, and I do hope we will be able to discuss in details the approach proposed by Russia on that point. Every shipping company voluntarily participating in the experiment. We pressed nobody to do that, and at the moment we have 3 volunteers participating. It is strict requirement for them to provide full-scale risk management in relation to trial. As already mentioned, every shipping company should report results to Maritime Administration, and Maritime Administration will inform IMO of the results. Shipping company receives some benefits from them, from the experiment, and have a right to reduce crew if proper safety arrangements confirmed by Federal Agency on Maritime and River Transport. Every party involved or somehow interested in the experiment should be fully informed of the experiment on every stage and should take every necessary action to provide safety of the trials. And I also should mention that the only Russian flagged vessel may participate in that experiment. Now we come to more comprehensive legislation drafted by Russian administration. Again, we expect the parliament next steps to approve this legislation very soon. One of the key points was mass terminology. As already explained by previous speakers, IMO approach has 4 degrees of autonomous vessels, but our investigations come to conclusion that those 4 degrees may be combined in 2. One of them, when crew still on board, we call that semi-autonomous vessels, and if no crew at all, we call in our legislation those vessels as fully autonomous vessels. Of course, every of those degrees then divided on 2, same as IMO recommended in the interim decisions. Specific requirements developed to shipping companies operating autonomous vessels, and special arrangements should be done by those shipping companies on safe management of the vessels. Our legislation introduces special requirements for crew still working on board of vessel, and we introduce special requirements to personnel working with autonomous vessel outside from the vessel and to remote crew. That's quite new idea in the drafted legislation, and we recently introduced that idea to IMO specifically for the forthcoming MSC session, remote crew. We all know that one of the obstacles of remote vessel is United Nations Convention of the Law at Sea, which strictly required from maritime administrations to provide crew for every vessel. So from our point of view, this requirement may be fulfilled by introducing the idea of remote crew, fully trained with functions and responsibilities, but working outside of the vessel. Also, one of the ideas we introducing in our legislation in future is specific mass operation company, which may not be a shipping company, but the company having experience and proper equipment and trained personnel to operate by remote crew, by the way, the autonomous vessels. There are some more interesting points in our legislation, but the explanation will require quite considerable time. At this stage, I would like to complete my presentation. Again, thanks for all the participants, and thanks to IMO participating in this conference, being with us. I do hope the ideas we introduced in our papers to forthcoming IMO meeting, MSC meeting, will help in further developments. And finally, our feeling that the question is not whether autonomous vessels will be. The question is when and how. Thanks a lot. And now I would like to transfer the floor to Fyodor Sushinsky, who is leading developer of technical solutions for autonomous vessels in our country, and I do hope he will continue on technicalities of autonomous vessels in Russia. Thanks.
Thank you, Vitaly. Let me introduce myself. My name is Fyodor Sushinsky, and I'm responsible for a-Navigation project external communication in Citronics Group. Let me start with sharing the presentation. Hope everyone can see it. Yeah. Oops. Hope it goes well. Yes, as an introduction, I would like to start with the goal of the a-Navigation. Yeah, here it is. Goal of a-Navigation project, it is to implement legal and technical conditions for widespread operation of mass by consumers. Mr. Alexander Pinsky mentioned it previously, but I would like to go through it one more time. Our planned roadmap is one that offers simple and gradual practical first steps that supposes 3 stages of autonomous shipping development: coexistence, transition, and prominence. At the coexistence stage, automatic and remotely controlled vessels shall be operated along with ongoing use of traditional crewed vessels within the framework of the existing regulation. The main goal of a-Navigation at this stage is to improve safety. That is to reduce the impact of the human factor, whilst simultaneously increasing control over the work of the crew on board by shipping companies. At the same time, automation of routine functions, better situational awareness, and control will reduce the burden of crew members and required manual on board vessels. The main barrier at this stage is the coexistence of mass with traditional ships, and we have addressed this by using the developed principle of complete functional equivalence. Complete function equivalence principle is the solution for the coexistence of mass and traditional ships at the first stage. It supposes that the autonomous mode will strictly fulfill the functions prescribed today for the crew on board by the current safety regulations. In order to implement this principle, the project identified key functions provided by the SOLAS 74, the CTCV code, and COLREG 72, as well as other regulations. We asked the feasibility, limitation, and expediency of automatic and remote control for each of these. We follow simple requirement in our project for automated functions implementation. Fulfill it strictly and in amount no less than the currently provided by the crew on board. As you can see on this slide, unique solutions are marked in red. Set of technical systems is universal, which allows us to upgrade any traditional commercial vessel to mass level. For environmental analysis, previously projects supposed to integrate only radar and ACE data, while using optical systems for remote, human operator control only. The same requirements are put in recommendation by most classification societies worldwide. a-Nav integrates all the data equivalently to an officer on board. The sensor fusion model integrates, synchronizes, and validates navigation data from different sources such as radar, AIS, positioning, compass, weather stations, etc., and optical systems. This is similar to an officer on board who has to gather data from all these navigation devices, his eyes, and integrate it into a single picture in his mind. The automatic collision avoidance model keeps the route and calculates the maneuvers of the vessel to avoid collisions with other vessels and navigational hazards in accordance with rules determined by COLREG. These detailed rules are provided by clear official recommendations from the Russian Federal Agency of Maritime Transport for automatic collision avoidance systems. Strictly determined algorithms of this nature make mass 100% predictable, even when placed in comparison with traditional cruise ship. The optical surveillance and analysis system is an optical system that detects and recognizes surrounding objects. It transmits these data in a machine readable from the NAS, while also sending the processed video image to human interfaces. The optical surveillance resolves the challenging task of fulfilling conventional requirements while providing visual observation in a completely autonomous mode while sitting in a parallel to human-operated remote mode. Although we are at the very beginning of the process of training the optical surveillance and analysis neural network to reliably recognize any objects in different conditions now. We believe that this automated approach that doesn't rely on human-operated remote controls will pay off in the future. And this makes a step further in comparison with simply moving human operation and oversight from on board to shore. At the same time, the optical surveillance allows us to improve the quality of situational awareness for humans, both on board and in the remote control center. Augmented reality and even completely virtual models, virtual reality, may become common everyday tools for navigation in the future. Autonomous navigation system performs the functions of automatic analysis of the environment, the passage along a given route, offering automatic decisions making on maneuvering while taking into account the parameters of the vessel and COLREG 72 provisions. NES includes the sensor fusion model, which I described before, automatic collision avoidance, and NES client, representing the extended version of this. The NES client integrates all the data from mandatory and additional electronic charts, such as ICs or setting images, and any other available information, and presents via human interfaces that are similar to this. The coordinated motions control system transmits NES commands to the ship actuators. It performs the same functions as the helmsman who converts the officer's orders to actions regarding steering and engine control. By coordinated motion control, we consider ship heading or trajectory control system, which is already used on a small but growing segment of high automatic vessels. Currently, coordinated motion control systems provide support through human control or follows a given trajectory with high accuracy while taking into account existing weather conditions and the ship model. By connecting coordinated motion control system to NES, we allow for the control of propulsion and steering both automatically and remotely. Regarding the vessel control, we use engine control and technical monitoring system. It is well known and widely used by shipping companies. These days, nearly any hardware can be delivered by manufacturers on board the vessels along with their monitoring, control, and even remote maintenance system. Therefore, we have simply moved the interfaces of the existing systems outside the vessel. And with the R meaning remote controlled, the RUTC gathers and transmits technical parameters and alerts to the remote control station. Together with the smart internal CCTV, it performs watch functions for the inspection and registration of events and checks parameters on board without interfering with the ship's rooms and equipment. Currently, vessels with high-class automation come equipped with the ATC that don't require the permanent presence of crew member in the engine room. With a-Nav, we offer the next step in this evolution, which is removal of the need for the permanent presence of crew member on the bridge. Internal CCTV provides various tasks like indoor video recording, automatic control over the conditions of rooms, movement, change of geometry parameters, etc., equipment, change of indications, switches, cargo, displacement scrambling, tilt, and other parameters, and the transmission of this video information to the bridge advisor and remote control station. The remote control station is a workstation for remote control operation and is designed to solve the entire range of remote monitoring and control tasks. It is located outside the controlled vessel and is the equivalent of highly ergonomic ship's bridge and central control station. The remote control station includes interfaces from for the operator interaction NES, joystick system for vessels motion control, and a set of terminals to the conventional radio equipment and loudspeakers on board of control mass. In remote control station main area, there are multifunctional touch screens for interacting with all the above systems, as well as joystick system terminal for interacting with the mandatory ship's communication and messaging equipment. And it is video camera for video communication with the crew on board. Above the main area, there are 5 screens that display image information received from the observation system about the current environment. They are present by default and display a viewing angle of 180 degrees in front of the vessel, while including the possibility of rotation of this field of view by the operator using the optical surveillance interface for viewing along 360 degrees up in the horizontal plane. This arrangement offers genuine angular dimensions of any object in the image displayed for remote control operation. The joystick system transmits the vessel motion parameters provided by the operator when in remote control mode. It includes a control panel and analog 3-axis joystick that has setting for longitudinal force, lateral force, and turning moment. Using the joystick allows the human agent to operate all the necessary actuators at once with a single control. In order to ensure interaction with the mandatory radio stations, ship, radio telex, Inmarsat stations, NAVTEX receivers, the remote control station is equipped either by separate terminal connected to corresponding devices on board, or by a single multi-channel radio equipment. All a-Nav elements are combined in one local network, including VPN tunnel between onboard system and remote control station. This local network is protected from unauthorized access using data encryption, a firewall to protect the perimeter, and control and restrict sockets. Any data exchange between onboard LAN segment and remote system is carried out by wireless communication channels. Depending on the mass, operation conditions, communication facilities may include satellite communication, mobile communication, direct radio link. Communication channels are reserved to provide permanent availability. Communication channels between onboard system and remote control station is protected by from unauthorized access with which may compromise that, of course, by the use of data encryption tools and virtual private network on top of the internet. This provides a secure connection between the node and the ship and the remote control station. Cybersecurity of this coastal remote control is provided according to the standards of the shipping company's information security. I hope it was some sort of entertaining, and hope it my presentation could show you how this system works. Thank you for your attention. I'm open for any further questions.
Thank you very much, Fyodor. Now we finish our presentation, and we have got a question.
I thank you for the question. As Duncan mentioned, definitely we will take into account results of trial operation, not only within the trial project, but during national experiment. But my subjective opinion, in the nearest future, we will have on the most of autonomous vessels people on board, but with a different function, with a different role. The major role of this crew on board will be dealing with emergency situations, with different technical issues, with repair, maintenance, and etc. Everything what was mentioned by Duncan. So just imagine just as an idea, instead of current 3 shifts on board of the traditional vessel, we will have 1 shift. Definitely, I'm not talking about passenger ships and etc., where we need the crew on board to care about passengers and so on. So we will have 1 shift. This shift will be involved into the ship control only in some limited cases. It should be something like emergency team on board. So if something is going wrong, these people are called automatically or remotely on board, on the bridge, and can take control and can deal with unpredictable non-standard situations which cannot be solved by navigation systems or by a remote operator. So I think, again, as I said from the very beginning, we are oriented on the gradual approach. So we understand that there are some functions and there are some risks which we cannot mitigate without people on board. So we will need people on board, but we will need specific people with specific role and in some specific number. I hope that I answered the question. By the way, may I ask, support Henrik with his answer regarding female seafarers? Because it is a very interesting and important topic. I understand it was raised by VISTA, Women International Association in Shipping. I absolutely agree what Henrik said, that through implementation of a navigation solution, we will make much better conditions for seafarers, and not only for crew on board due to unload from different functions and etc., but also for navigators who will be relocating ashore. You know, female drivers are much safe and accurate in accordance with statistics all over any country. But how many navigators, what is a portion of female navigators do we have now? Very small. And I think that introducing these navigation solutions into the practice of shipping companies, we will open up opportunities for new categories of navigators. Definitely, these are female navigators. Definitely, these are age navigators or navigators with some limitations in health. We have many skilled professionals who cannot go on board due to some health limitation or family conditions. So we will open new possibilities for many new categories of navigators, of seafarers, and it will be in benefit not only for the seafarers, but for shipping companies as well. You know that currently, in accordance with the IMO statistics, there is about 20% of deficit on professional seafarers all around the world. And implementing a navigation, we will not only improve gender diversity or age diversity. We will cover this deficit. We will open much more opportunities for shipping companies to hire skilled professionals and to utilize their competences in the operation.
I think Mr. Pinsky answered that question quite comprehensively. But this is also connected to the next question in the chat, which is, can it be done by people that have not been navigators before in a previous life, before they start these remote operations? And that's a very valid question. Do you actually need somebody in a remote control station, somebody that has had practical experience with ships, or can you just train people to be able to react to situations they might encounter, even if they do not have the practical background? That is quite a difficult question.
Well, right now, our legislation, which is adopted in Russia, including the decree by government, supposes that a remote operator could be only certified seafarer, navigator, with practical experience in the specific class of vessel. So right now, our answer that we cannot put on the remote control station anybody else skilled and certified navigator. I don't know what will be in the future, but currently, again, since we are following functional approach, I understand that as TCW convention and code doesn't describe remote personnel, it is applied to the crew on board. But since the remote operator will fulfill the functions described in the convention, we think that competences and training of such people should be in line with the TCW convention as well.
Thank you, Alexander. We have got a question about ice condition for.
Could I just add some if possible?
Yeah, of course.
Yes, thank you. I just wanna touch briefly upon the question about more women in shipping, and I think it's more diversity in general. I think it benefits all organizations. So it's gender, and it's also cultural backgrounds and ethnical backgrounds, etc. And of course, not using 50% of the population in an industry weakens the industry. I mean, it lowers the competitiveness of the industry if we don't get more women engaged and willing to work in our industry. So I think it's a key for the future to get all of the best into our industry. And maybe alluding to what Alexander said, women take less risks, and we want to reduce risks through navigation. So maybe we would get an even bigger impact with women and navigation in the industry. So I think we can see added potential there, definitely. And also on the remote operator, as I said during my presentation, the remote operator is one of the common gaps and themes that we have found out to be that we need to address sometime in the organization. If it's supposed to be a seafarer, how to define it, what requirements for certification, etc., on that remote operator. And there are also, I think, there are also other projects in Europe on that, bilateral, multilateral projects, trying to figure out, as in Russia, of course, trying to figure out the relevant level of background, professional background, experience, etc. Should it be a seafarer or any particular certificate holder, master, etc. So there's a lot ongoing, and there's also revision of the SSCW convention, and this might be something that is addressed also in that revision. I'm not sure, but I've heard rumors to that effect. And when it comes to, this is my last point, when it comes to the whole approval of a ship, of an autonomous ship, a mass ship, I think there's also there's possibility to look into alternative design and alternative approval equivalencies. And we have the circular 1455, which I know Norway is using in their efforts to certify Yara Birkeland and ASCO for autonomous navigation. And that's not in international voyage, but it's still, their national legislation is the same basically as the international legislation. So they're using this process of alternative design and approval in order to get the same level of the safety. That's of course that's the goal, that we need to have the same or higher level of safety when we use mass. So there are different ways to go, and in the interim, when we don't have a legislation internationally, or in most countries we don't have international legislation on mass as you do in Russia, which is terrific. Then we need to be creative and use the means available to us, and there's the 1455 circular is a good way, I think. So that's just my comments thus far. Thank you.
Thank you. And we have another question about a little bit earlier. It was about ice condition for mass. Could you probably it for the Alexander Pinsky?
Well, no, currently we consider ice condition in accordance with, if I recall correctly, with the SOLAS or STCW definition as a navigation in extremely hard conditions. So for now, we consider that it is not possible to do it in automatic mode, because there are too many factors which cannot be predefined and calculated. At the same time, as I mentioned before, we are trying to gather data to understand how we can deal with this. And one of the options is the convoy navigation. As I said, if we have icebreaker and vessel following them, we can following the icebreaker. We can use actually automatic and remote control for this convoy vessel, and we'll have only one crew on board of icebreaker, and the rest ships will be could be even totally unmanned. But again, for now, we are just experimenting. We don't have clear answer. If the same as about the next question regarding port fleet. Definitely we will need additional solutions, and we don't have solutions right now. We plan to develop next stage of navigation in Russia, specifically focused on port operation, meaning to allow automatic and remotely control entry and exit and mooring, even for ships which are not equipped with onboard automatic mooring or DP systems. So we are in the process of such preparation of such developments. I think maybe in 2 years we will see systems which allow to equip ports for work with any ship, but with such autonomous mode inside port. And definitely, if we're talking about trucks, we are talking about different small ships and even unmanned boats, you know that there are many experiments worldwide with small boats. They are not covered by international regulation as a commercial merchant fleet. So it's much more easy to deal with these experiments. So I think here, you know about the progress, and I would say that this small boat is much more easier challenge rather than implementation of autonomous navigation in merchant fleet.
Thank you, Alexander, and probably for your question about the data transfer via the satellite.
You know, actually, one of our findings, the communication is the main painful, I would say, area for us. Why? Because we are trying to deal with the existing satellite channels. So we understand that usually a normal shipping company could use something like about 2 megabits per second capacity channel per vessel. And we are trying to utilize this standard channel. What is very tricky? First of all, very tricky regarding video data transferred from autonomous vessel to the remote control station. In the video which was presented by Mr. Deputy Minister, you see the trials when we had satellite communication channel even less, something like 1.2, 1.8 megabits per second. And as you saw, we could work even with such conditions. So yes, communication is very important. As better communication we have, as better remote control we will have. It is not very important for automatic control, but it is really important for shipping companies, because shipping company, any shipping company right now, wants to control vessel even in automatic mode, because it is something new. They would like that their operator will control what is happening on board. And I would say that at least we know how to deal with such communication channels. We developed, as Fedor mentioned, several modes of visualization of data, including virtual reality. When we have, for example, extremely poor communication channel and, for example, bad visual conditions. So I would say it is a very critical point. I believe that the development of maritime communication will help us. You know about Starlink, about OneWeb. So yes, communication is very important, and everybody who will implement navigation will face with the same challenge as we faced, that we need to utilize pretty moderate, pretty small capacity channels which are currently used by shipping companies.
Thank you, Alexander. And we've got a question about the standard testing protocol.
The simple answer here is to use Express. Of course, we installed the system on 3 different vessels, or 3 different purpose vessels, although they are all called commercial. And we have 3 different captains, 3 different crews, 3 different ship owners. In terms of learning the optical system, we have to use the experience of the captains, experience of the people who actually know how it works. So we try to learn the system to provide it enough information if it is correct, the decision made by the system is correct or not.
I think it would be useful for participants. You know, we have in the optical system, we have 2 different tasks. One task is the automatic recognition of different objects and sending it in machine reading form to the ANS. It's something like optical radar, which is working 360 degrees in nearest zone, which means up to 5 miles in traditional and infrared range, and far zone up to 12 miles. So in this task, optical systems recognize and provide data automatically. The second task, is to provide video data for human interface, either bridge advisor on board or a remote control station. So what is interesting finding? It seems that for best recognition, we will need to use not visual range, but infrared range. So for automatic mode, infrared, different combination of infrared ranges would be much more useful. But it is absolutely different from, how to say, familiar view for the human eyes. So it seems that we should understand that for automatic recognition, we will use, for example, a specific machine vision algorithm, which could be more and more different from traditional human eyes. It is very interesting output from our practical experience, which I think should be utilized by our colleagues who are developing the same systems. So one task is to provide traditional visual data for human eyes. And another task, which probably is absolutely different, is to provide automatic recognition, which should be used different ranges, different algorithms, rather than used by human eyes, by human brain. And actually, this is the answer for the last question, that optical system is intended to find small targets or vessels which are not equipped with IS and which cannot be identified by automatic identification system or with radar. So actually, how our sensor fusion module is working. It is gathering data from radar, from IS, from optical systems, and validate, is it one object or not? If we find, for example, that something is found by radar but is not presented by IS, we understand that this is a new object. If we find, for example, that something is found by optical systems and not visible on radar and IS, it is also another object. So we are gathering different objects independently. Is it visible on radar or IS or not? By the way, in this video from trials of Poland FISA, I looked at this yesterday. At the end, you will see green and red dot, something like 1 mile near the vessel at the end of the video. This is exactly when some target was found only by optical system, and it was not confirmed by radar and IS. So this is something which why we need visual observation by human, because sometimes technical vision like radar and IS can pass some objects, and only human eyes can detect it. So absolutely the same, in accordance with complete functional equivalence, should be done by optical systems.
Given me an unexpected, quite a difficult task here, but I think your conference was very interesting. Not only because it goes much further than where we are currently in IMO with developments, but also because it raised a number of issues that we have currently not considered in IMO. I learned quite a lot, and I was especially interested in hearing about the Russian efforts regarding convoy operations. That is a very interesting concept, I think. But also, we will have next week at the 103rd session of the Maritime Safety Committee another working group on MAS, with the intention to finally bring the scoping exercise, the regulatory scoping exercise, to an end. and you will have HENRIK TUNFORS chairing this group again. Should the group manage to finalize, and there have been lots of contributions from member states, not only documents submitted to the last session of the committee, where unfortunately due to time pressures we didn't have time to consider the issue, but also a huge number of documents, including quite a number of documents from the Russian Federation on various technical issues, which will all be considered. If the outcome of the regulatory scoping exercise can be agreed by the committee, then the actual technical work will follow. And that's where we then get down to basics, to what actually needs to be done technically to enable MAS to operate. And there the burden is on the member states, not on the IMO Secretariat. What we expect then is member states to consider what issues exactly need to be technically considered at IMO, and solutions to found that are internationally agreed and implemented. So with the finalization of the scoping exercise, the work will start in earnest, so to say. And I'm sure we will for many, many years, probably next 10 years, work on issues related to MAS before international agreement is reached there. Yeah, that's all I have to say. Thank you very much for these very interesting presentations.
Thanks a lot for the summary and finalizing this conference on behalf of the Ministry of Transport of the Russian Federation. And I would like to say thanks first to participants, speakers, HEIKE to you and to Henrik. Both of you were very interesting for us, and we learned a lot from your side. We learned a lot of your approach. Also, I appreciate participation of those who didn't speak but joined us. I do hope you received some more information on developments made by Russian Federation internally and externally, and as you may see in contributions to forthcoming committee meeting, we are trying to be active in the developments, and I do hope our voice will be heard by a group leader, by IMO members, and autonomous vessel will become in fact in our seas, and what is very important, those vessels will be absolutely safe for people, for environment, and will promote shipping. Also, some interesting questions arrived from chat of the conference, especially for women involved in the activity. Of course, being close to family, to children, these seafarers, if we may say in future seafarers, work will be more attractive for women as well. Again, thanks a lot for participation, for discussion, for presentations. All of them were very, very interesting and useful. And see you in the nearest future in IMO meetings. Thanks a lot, and by this I conclude the conference. Of course, the presentations will be available. Organizers will provide you with the presentations they did. Thanks a lot, and goodbye.